Hi guys, today we are going to discuss a problem of finding a critical numbers of a function in product, as it like containing some products using chain rule and the product rule. Here is an example. So f of x is given to be x squared minus 5 to the power 4 and x squared plus 9 to the power 8. So it's just a product of these two factors. What are the critical numbers of this function? Critical numbers, critical points. So first I'm going to differentiate this and then set it equal to 0 and then find the values of x for which the derivative becomes 0. Because this function is a polynomial, it is well defined everywhere, so there is no point at which the function is undefined. So everything is well defined in here. So here is the solution then. Let us differentiate this function. Alright, so the second factor, remember the derivative of p and q. Keep the second one to the power 8 and then now differentiate the first one using the power rule or chain rule. 4 times x squared minus 5 and then you subtract 1 from the power and multiply with the derivative of inside in here, this quantity. Derivative of x squared minus 5 is 2x. So I'm going to put it in here, plus. Now to keep the first one. Now differentiate the second one, 8 times x squared plus 9 to the power 7 times 2x. Okay, now let's look at what's common in here. So in here the third power is common, fourth power, third power, so there are 3 of them in common. X is common, 2x is common, 2x is common, 4 and 8, so 4 is common. And then there are 8 of them in here, 7 of them in here, 7th power is common. So let's look at the common factors and then pull this out. So you can just write this as a common factor. Common factor is 8x first of all. Another common factor is x squared minus 5 to the power 3. Another common factor is the 7th power in here, x squared plus 9 to the power 7. So what is left is, from here, we are left with x squared plus 9. And there is nothing else. And then the other one, because we just put 8 of them in here, these are 8 times 2. 2 is left. 2 times and then there are 4, so we put 3 of them out there. So one of them is left in here, so x squared minus 5. Alright, now if you distribute this 2, we get 2x squared minus 10, right? So what we have is 2x squared minus 10. So if we add them up, then this factor would be 8x times x squared minus 5 to the power 3 times x squared plus 9 to the power 7 times, and the third factor is 3x squared, because 2x squared from here, another x squared is 3x squared, and then minus 10 plus 9 is minus 1. Okay, this is our derivative f prime, and I'm going to find the critical numbers of this. So I'm going to find the values that makes this 0. So in a sense, we are finding the points at which f has a horizontal tangent line here. So either in this case, this factor is 0, or this factor is 0, or this factor is 0, because x squared plus 1 is always greater than or equal to 9, and then power 7, so this whole thing is greater than 9 to the 7 actually. It's a very big number. So these are the 3 possibilities. Let's write them. So in here 8x is 0, so x is 0, or x squared minus 5 is 0, or 3x squared minus 1 is 0. Okay, so this tells you that x equals plus minus root 5. And then this tells you that x equals plus minus 1 over square root 3. So in this case there are 5 points, right? So if we summarize what we have done, critical numbers of f of x are x equals 0, x equals minus root 5, x equals root 5, x equals minus 1 over square root 3, and x equals 1 over square root 3. Alright, that's it. There are 5 points in here. I hope this helps. Thank you very much for watching, and see you later.